Welcome to the course of Wireless Sensor Networks. I'm your instructor Zeeshan Bangash, and this is lecture number 22. The discussion topic for our today's lecture is protocol vulnerabilities. So let's move to the agenda of our today's discussion. So in today's discussion, we will talk about some of the protocol vulnerabilities to denial of service attack. Then we will discuss the rate control adaptive policy. We will discuss another protocol called the RAP and some of its vulnerabilities. We will also talk about how routing in WSN be implemented in a secure way. And in this, we will be discussing about the differentiation between, or the differences, or the difference of WSNs versus the ad hoc networks, some assumptions for the threat models, and some attacks like sinkhole, Cybele, Wormhole, and HelloFlit attacks, and then some attacks that are for the routing protocol, and at the end we will discuss some of the countermeasures to cope up with these attacks. So let's discuss the first agenda item, that is about the protocol vulnerabilities to denial of service attacks. So analyzing these vulnerabilities helps show why developers should consider denial of service suspectability at the design level. So this is of the main concern, that whenever you design any security mechanism against the denial of service attack, you need to first of all understand the different attack patterns, particularly the different version of denial of service attacks. Now, adaptive rate control. It gives preference to route through the traffic. And this mechanism preserves the network investment in packets and that may have already traversed many hops. So this is the advantage of this type of mechanisms. So this mechanism, this scenario can make flooding attacks more effective. Now, high bandwidth packet streams an adversary generate will receive preferences, and thus the network gives preference to malicious traffic. Now, this is basically the details about the adaptive rate control. Now, about the real-time communication architecture. RAP is a real-time communication architecture that works on the geographical forwarding, and it works on velocity monotonic scheduling policy. A deadline is set by the originator of the message towards its destination. The velocity monotonic schedule policy, or the velocity VMS layer, it computes velocity based on time to deadline and distance remaining. Now there are some vulnerabilities that this protocol generate floods with high velocity packets. Now they can set the destination at a longer distances, and most probably outside the network. This is another concern. Now, intermediate nodes adversely could lower the velocity of route through traffic. So this is another limitation of RAP protocol. Now, it causes the deadline that mostly misses. And if rely on the synchronized clock, in this case, the attacking that mechanisms could cause another node to always drop. So these are some of the vulnerabilities that can create a bottleneck if we use RAP, and this protocol has some vulnerabilities in itself that needs to be addressed before implementing this protocol for wireless sensor networks. Now, we need to protect the clock synchronization, yet important problem it's an important problem in itself. Now, there are some attacks for wireless sensor networks, particularly in terms of securing its routing. And in the upcoming slides, we will also be discussing some countermeasures. Now, key contributions includes that there are some secure routing issues in WSNs. There is difference of WSN from the ad hoc networks. Two new attacks have been introduced, which are the sinkhole attacks and the hello field attacks. Now we need to analyze security aspects of the major routing protocols in our upcoming discussion, and we will discuss some countermeasures and design considerations for a secure routing in WSNs. So let's differentiate between a WSN and an ad hoc networks. It's basically multi-hop wireless communication. The WSNs are multi-hop wireless communication, whereas ad hoc networks, it basically communicate between two arbitrary nodes or more than two arbitrary nodes. WSNs are specialized communication patterns from many nodes to one node, or one node to many node, or some local communication in a cluster head, and it is more resource constraint oriented network than the ad hoc networks, and there is more trust needed for in-network processing in wireless sensor network, more trust in terms of aggregation and duplicate elimination in wireless sensor networks than the ad hoc networks. So challenges and the protocol vulnerabilities are more in WSNs than in the ad hoc networks. So at WSN introduces new challenges for the designer. Now there are some assumptions, like the radio links are insecure. Now another assumption is that malicious nodes can collude to attack the WSNs. Third assumption is that the any sensor nodes are not temper resistant. And another assumption is that the attacker can access all key material, data and code because the nodes are physically distributed openly in an environment. Another assumption is that the points that have been allotted for aggregation, that may not be trustworthy. Another assumption is that the base station is the only point that is trustworthy. Now let's discuss threat models, or some of the threat models. Now this device has some capability that it is a mode class of attacker, or it can be a laptop class of attacker that the attacker have more energy, it have more CPU computation capability, it have very sensitive antenna and a very powerful radio power capability. So it's a more powerful node. The threatening node or the attacker node is basically a very powerful node. Another thing, that the attacker type may be an attack from outside attack that is external to the network, or it may be an insider attack, any malicious node within the network that is authorized in the WSN, or that may be compromised. Now the goal is basically in our upcoming discussion is that's how the security mechanisms be secured, and how it needs to support some of the security key parameters like integrity, authenticity and availability of messages in the presence of an attack. So the whole application needs to support all these things, and then it supports the data confidentiality. Now the attacks have been classified as either it's an attack on a general WSN routing or attacks on a specific WSN protocol. So that needs to be classified. Now, what is attack on the general WSN routing protocol is that the routing information is either changed, replayed, or it is spoofed. Now, what happens if that routing information is spoofed or replayed? That it will create loops. It will attack or repel the network traffic. It will segregate the network communication, or it can attract or repel network traffic to a certain point. So these are some of the vulnerabilities when a routing protocol attack is launched on any network. Now, how to overcome that? The message authentication mechanisms can be implemented, then can partly or to some extent handle these issues. And second thing is that in attack on general WSN routing protocol, the selective forwarding mechanisms undertook place, in which the anomalous node or the malicious node select some packets uh, and select, after processing it, forward this packet to the destination. Now, another attack pattern is the sinkhole attack, and this is very specific to wireless sensor networks than the ad hoc networks. That all the packets are directed to basically a central point, which is called a base station, and all malicious nodes in the network tries to advertise itself as a very high quality link to the base station. In this way, the nodes in a multi-hop communication try to send its data to the destination through this adversary node, and these nodes try to attract a lot of packets moving to the base station through the malicious nodes. So a sort of a sinkhole is created toward the base station. Now, it will enable other attackers, for example, selective forwarding or wormhole attacks. Another version is the Cybele attack, which is again a flow control attack, that a single node try to be present at multiple places at a network. So this node try to portray itself or validate other nodes that it is part of their network, whether and actually it's present at some remote location. Now, after geographical routing or distributed storage, multipath routing, topological maintenance, this attack can be avoided. Another attack is the wormhole attack. It's basically two colluding nodes, and a node at one end of the wormhole advertise a very high quality link to the base station, and another node at the other end receives the attracted packet. So basically, this attack also disturbs the valid flow of the packets. And then there is a hello flood attack. This is also very specific to WSNs, and in some protocols that nodes have to periodically broadcast hello to advertise themselves, and this is not authenticated. They are basically launched by the laptop class attacker that have very high in computation power and energy, and they can consume its neighbors of distance nodes by sending high powerful hello messages. Now, another type of protocol vulnerability or a sort of attack is the acknowledgement spoofing, where the adversary spoof acknowledgement to convince the sender a weak and a dead link support good link quality. So it spoof the control information that is flooding that is moving in the network, and try to make the senders or the neighbor nodes believe that these links are very dead links by updating or changing the acknowledgement packets. Now, there are some attacks that are very much specific to the routing protocols, like tiny operating system beaconing. It's a very specific protocol on the tiny on the attack on the tiny operating system, and it construct of a BFS rooted at the base station, and beacons are not authenticated in this type of attacks. And adversary can take over the whole WSN by broadcasting beacons that are not authenticated. Similarly, another protocol specific anomaly or attack is the directed diffusion, and basically it works on the replay interest mechanism, and that can selectively forward the packet, and it basically tampers the data. It injects the false information within the network. Similarly, another type of attack specific for routing protocol is the geographical routing. Adversary can provide false, possibly multiple location information in the network, and that will result in creating a routing loop, and as a result that packets will stuck in that routing loop and will not reach its destination. Now, gear considers energy in addition to location. So, a laptop type of class of attacker that have more computation and powerful capabilities being used in such type of geographical routing protocols in making anomaly. Now, there are some countermeasures. One of the countermeasures to address these attack or to cope up with this attack is that the key used needs to be shared, and a layer level encryptions needs to be used in order to avoid collision. That can prevent outsider attacks like cyber attacks or selective forwarding or acknowledgement spoofing within the network. So this shared key and link layer encryption will help to avoid the outsider attacks. However, these it have limitations that it cannot handle the inside attacks like TinyOS beaconing or HelloFlat or Wormhole attack. And another attack for cyber attack countermeasures is that every nodes in that network needs to share a unique secret key with a base station. That will create a pairwise shared key for message authentication, and that will be used for message authentication. And this attack can be avoided by limiting the number of neighbors for a node. Similarly, another some countermeasures for hello flood attack is that the link between a sender and a receiver needs to be verified by directionality, and if the affectee has very sensitive radio, so this countermeasures will not work. Some more countermeasures for attacks like wormhole and sinkhole attacks are that cryptography will not help in countermeasuring these. So the protocol design need to be revised, and geographical routing mechanism and the information related to the location needs to be incorporated. So that will help to countermeasure these attacks. Geographical routing like location, in which some location verification and some fixed topological use needs to be made part of the routing protocols or the security protocols that will help to fix these attacks. Now, for multi-selective forwarding, multi-path routing mechanisms needs to be incorporated. Now, the root messages or a disjoint and braided paths needs to be used, and there needs to measure the trust level in the overall network, and accordingly some identifier needs to be assigned. And similarly, a mechanisms needs to be implemented that if an anomaly happens or any node's behavior is observed not fulfilling the trust level, so its trust level can be dropped. In this way, you can establish some black hole areas, some gray areas, and some green areas in the network, and on the base of that you can transmit your information, or the algorithm will classify that the nodes as per the black status or the gray status or the green status, and accordingly make them part of the routing, and intelligently decide that the information needs to be hopped through which node. So these mechanisms needs to be implemented. Similarly, some more countermeasures are using authenticated broadcast like Tesla, and we need to incorporate base station floods the blacklist among the networks that needs to be authenticated, so that the blacklist information needs to be made available to every clusters, and that information must not be spoofed, and that must be communicated in a secure way. So this is the reference from which this the content has been taken, so you can just consult it. And thank you very much for patiently listening. Take care. Allah Hafiz.